again, the way how you could solve this would be to solve maybe this formula here for W and then plug it down in here, right? So then you have the sigmas and the mu's in one formula. It's a ridiculously long and complicated formula that doesn't add any intuition. So I created this graph basically using the numeric approach in Excel. I create one column for the W in the first column, and then I compute, given a certain value of W, what's my expected return of the volatility. And then I have a pair of values that I can easily plot in a graph. So these are the formulas that we developed this morning, and this was basically the reason to show you this plot that comes next. So now you see several curves here, and every curve represents a different correlation level. So I've picked 5 levels. So the straight line that you see here at the bottom, that's the correlation coefficient of 1, and the triangle kind of shape here, that's the correlation coefficient -1. We can annotate our assets in here. So this is asset B here, and here we have asset A. And the curves in the middle represent correlation coefficient of -0.5, 0, and +0.5. Now in the extreme values, when they're positively correlated, you see that it's just a straight line. When they're negatively correlated, it's a weird shape. So you first go back to the y-axis, and then from the y-axis you go up there. Right, so the correlation positive is kind of the case that we had before. And this one here, where they're negatively correlated, is actually quite interesting. So a negative correlation means they work in the opposite directions, right? So what you can do is you can find a combination of the two that is absolutely risk-free. Right? And that's this combination here. So if you end up here, the volatility of the portfolio is exactly 0. Right? But it has a positive return. I'm not quite sure what the portfolio weight of this is, but maybe judging from the numbers.
Shouldn't it be on the peak of the curves?
Well, let's quickly keep it on the top. So the condition here is that W times the return of the first asset was 10% plus 1 minus W, the return of the second asset, is 25%. That seems to be exactly 15%. So we'll have to back up quickly what this is. W times 10%. Minus 25% equals to 15% minus 25%. So with minus 5 divided by minus 15, so that's 1/3. So we buy 1/3 portfolio weight for the first asset, 1/3, and it's 2/3 of asset B. That's the correct combination. If we mix the assets in that fashion, we have an exactly risk-free portfolio, but it has a high expected return of 15%. And really this has volatility 0, right? Because every movement, up movement, and the other is offset by down movement, and so on, right? And we can kind of make a perfect kind of match between the two. So all the other curves that you will see here are in this triangle that's kind of given by the -1 case and the +1 case. Right? So all the curves that you will ever see are within such a triangle. And by the way, I should note that there's no short selling in here in this picture, so all the portfolio weights of both assets are positive. But it's easy to extend that. You would have basically every line would extend up to the right corner and at the bottom. Right? So it's feasible to draw that, but I didn't want to overload the picture here. What we see for the curves in the middle here, they all have this shape here, and the shape is called a hyperbola. Right? So all that's the standard case that you'll see in the data that we're also going to we compute such a curve for real assets before the break in the empirical case study. And all those curves are hyperbolas. Right, if you want to draw a hyperbola, I actually suggest that you draw a triangle like this, and then you have a shape that kind of gets closer to the triangle at the upper left and the lower right. That's kind of the way how we draw a hyperbola. So what you can see here actually is that if you create a portfolio, let's maybe look at -5 or 0.5 correlation, this is the risk of 10% of the smaller risk of the two shares. You can actually create a portfolio which has less risks, right, than the individual components. And that was the case that we observed with this electric car manufacturer and vaccine producer in our example. Right? So you can create a portfolio which is much less risk here than each of the individual stocks. And even if they're totally uncorrelated, so for rho equal to 0, you can still see this effect here. Right? You can still end up at a smaller place here. The point on these curves, which is exactly to the left, which has the lowest risk here, has a special name. This is the so-called minimum variance portfolio. I'm not quite sure why people have stuck to variance here and not volatility, but they're in the same direction. So if it's minimum variance, it's also the minimum volatility. So if the minimum variance portfolio is to the left, or has a lower risk than the risk of the individual components, we speak of diversification. That's how you can now see this graphic. What I find remarkable is that even if those things are totally uncorrelated, like in this case, you can still kind of create a risk reduction. Right? That's the middle curve here. You can still create a risk reduction. Well, for this curve here, it doesn't look like a hyperbola anymore, but if you continue it, would look at the same shape to the bottom. Right? That would involve short positions in asset A probably. Or known as a B probably. Right. So, but the general curve is still kind of a section of a hyperbola. So at this point, since we're not doing kind of the mathematical derivation, I hope that you trust me that these results are correct. And again, we're actually deriving these plots using actual data. So I'm going to ask you to choose a couple of stocks that you're interested in. And we download the data from the internet, from Yahoo Finance, and we will compute the portfolios out of these two stocks. I'm going to show how this looks like. Right, and then hopefully we make a good choice, then these are stocks which are kind of not so positively related, and we have a nice hyperbola and can kind of find out which stocks work best for diversification. So, more for the sake of completeness, I've provided a solution on the next page to actually find this spot here. So, minimum variance means that you would take this formula here, and that you would find the minimum value for this. How do you do that mathematically? You would create the first derivative, set this equal to 0, and then you solve for the portfolio weight. Right. So that's something that you can mathematically do. And you've all done this probably in high school. So this is the solution, right? So this is the portfolio weight of the asset B in this case, of the minimum variance portfolio. So it's basically the first derivative of the variance function set equal to 0. So you get to this by solving the first partial derivative of the portfolio volatility or variance probably, with respect to the portfolio weight, and then you set this equal to 0. And this thing is called first order condition, FOC.